Yeah. So I think you also have the codes that you're supposed to be using, and we'll maybe start by talking about what we call functions. Do you know any example of a function? We've been writing things in R for the past so many days. Do you know any example of a function? You can list down examples of functions that you've worked with. List down examples of functions that you've worked with. Ronnie, example one, give us two examples of functions. Unmute. Pashamai, while Ronnie is unmuting, I think it's taking too long to unmute. Pashamai, functions that you've worked with in R. Ross, you can also type in the group in the comment section functions that you've engaged with. Joseph,
Hello, sorry. I remember function some one I read in JavaScript in user defined functions.
uh-huh.
Yeah, I can remember that. Yeah.
And you can remember that. But any other that you've worked with in R? Yes. Have you worked with any function, Ronnie, in R?
In R, not yet.
Oh, not yet.
Yes.
Pachimai, have you worked with any function in R? Pachimai is not. How about Victor?
Not yet.
Not yet.
But
Joseph?
is else if a function?
Okay, we'll answer that. Joseph, have you worked with any function in R?
Yeah, basic arithmetic functions.
Yeah, I was asking that question to see if we are keen enough to realize that we've been working with functions. For those who are saying no, I have not worked with functions. You have actually been working with functions here. Um, and we have two types. So of course we do have like the built-in functions, and then we also have the user-defined functions. User-defined. Okay, so we have built-in functions and user user-defined functions. So you've been working with functions. So for example, when you talk about maybe calculating mean of something, it's a function that has been programmed. Yeah. So what you are doing basically is just to be calling it to action every time, right? I had to get mean of maybe one. Is it going to work that way? 1, 2, 3. It's telling you that it's one. What are these? Um. Okay. Sorry. This should be. Suppose now maybe we are getting the mean of these numbers. Are we going to get anything really? So this is more of like we're trying to get, so we eventually it's 52. So this is a summation. We are doing a summation of, so suppose maybe you are getting mean of something like, let me use mtcas, or even what I was doing, like mean is a function, sum is a function, control Z. Sum is a functions, right? We have a sum function. Sum function. We have that as a sum functions. You can even do a summation of those numbers that you are working with, that I was writing here, or you can even get a mean of a certain data like mtcas, mtcas what mpg. I don't know if that is something that is, yeah, mean of mtcas mpg 20.09. So this is a function, right? And it was written maybe, how can a mean be written? Yeah, a mean function. So maybe call it something like even mean, and say this is a function. And again, function, you declare it by this way. So function. So what does it do? Sorry, what does it do? Maybe it takes some values that are inside something and maybe adds them and divides by it. So maybe you have a1, a plus b, what is this? A plus b plus c. I'm just trying to write a dummy thing here. Up to n, sorry, plus. So you're doing maybe a summation of all these things. I'm just trying to look at how linear will look like. You're doing a summation of all these things and maybe you're dividing by it's a function that takes numbers and adds them and divides by n, right? So this one should be nth. This one should be nth number. This n is n for the number of values that you have, right? And brings you the output, right? Yeah, I mean, like, so that is what has been programmed there, so that every time maybe you call a mean, you call this mean function, and then maybe input a certain value that you have, it's just going to be doing more of a summing all those things and dividing by the total number of data points that you have. So kuwe kazi yako ni just inputting things. If you want to do a summation similar to that, you want to get a square root, right? Sindio? Square root function, right? You want to get a square root of maybe 81. Yeah, it is a function that has been defined and programmed there. So every time you do it, you don't have to write like that function. So kazi yako ni just to throw in some values. Any other example of a function that you can think of? These are just basic ones that I'm mentioning here. Any other function? Even paste. So okay, functions in R, you'll find them with ending in this, right? You can see those parentheses. Yeah, you can see the parentheses. So you'll find functions ending in there. So that is a function. What else is also a function? Another example of a function that you've met. We've done so many of them, right? We've done tail. Tail is a function, right? To show you like the last 6 entries in a data, right? We've done even things like supply, right? That is also a function. We've looked at things like what? Summarize. This one, summarize, summary. These are functions that are in R. So thousands of functions, I mean, that are present there in R. It depends on what you want to. We even looked at things like maybe glimpse. Glimpse is there, right? That is a function that you can use in R. Scheme without charts, that is a function, right? Let me see. It's a function, right? Is it a function? Scheme without charts. Yeah. And then that is another one that we looked at. So these all these are functions. Yeah. And even when you get to something like Excel, you also talked about functions. Yeah. Examples like count is a function, sum. We looked at Power BI, sum X, when we were talking about the data expressions, right? The data analysis expression language. That is the Dutch language. You looked at functions, and then you looked at even the ones that you can define for yourself, right? There are those ones, the counts, the sums, the sum X, the sum, the count X, counter, and things like that. And also there are those that which you can define by yourself. Okay. So that is built-in functions, and there are so many things that built-in functions. You can even get correlation, right? Because there's also even function for correlation, for correlation, and you can even do like a correlation test, yeah, between two data sets, or maybe two variables. You want to do a correlation test between two variables, right? That one you can do. You want to do maybe a regression test, or maybe you just want to do a regression. You can do that. You can do even like the ANOVAs and things like that to generate the outputs that you want. And so what I mean is there are thousands of functions. You can even check like the exact number of functions. Ask how many functions are there in R. How many built-in functions, I mean. Anybody has gotten? Yes? Okay. Yeah, you'll check that. We have even like those ones, the minimums and the maximum. The maximum. You are using them so much in the first assignment that you are supposed to be doing. Um, Another thing also now, those who are built-in functions. So built-in functions are already have already been defined for you, right? So you may just need to be calling them and doing whatever it is that you want to do with them. Um, so we can just maybe again even look at user-defined functions. Functions can also maybe get complex as complexity increases with what you want to do. So we may look at simple ones first. For example, how do we write maybe a square function, right? Yeah, and you can look at this example that we have here. You can call it anything, right? It doesn't have to be like you may andika square, but of course you want it to be making sense. Yeah, you can even write. Okay, let's start with this. So there's this square as the name, and then we have the function, right? So this is more or less like the skeleton of a function. You'll see us writing function, and then you'll see us writing what are we supposed to be returning. So with this return, yeah. So suppose maybe you want to calculate to write a function that returns for you the square of a number, right? So first you have to know that a function has to have like these curly brackets, right? There's that time when you are talking about subsetting and then you are using the square brackets. Now that place where you found the square brackets, on top of it, it is curly brackets. So curly brackets, those are the things you're using in writing the functions. You're not going to use this parentheses. If you use the parentheses, it's not going to run, right? So we have this square, then we have function. So inside that function, like what value are we passing in? And then you can see we are calling it x. You can even call it call it y, or even call it even h, or even j. I mean, these are just what do you call them? These are just like placeholders. I mean, so you have function. So this one has to be in brackets, right? So the first thing you're writing, even if you start just writing function, you'll see that tayari inakuletea that parenthesis. So it has to be parenthesis first. After that, write the square, sorry, the curly brackets. Then you can tap that one iende uko chini, so that you write now your function hapa katikati, an answer that you want to be writing, right? Of course, it's not. Yeah. So that is how you'll figure you'll think of it. So first there's function, right? And then function has to be, so let me see. So function, then maybe x. Then a function has to to have a name. So for example, this name we are calling it square, right? So what is the square of a certain number? Then now we declare that function. That function, so function in bracket x. So whenever we pass a value x or something, or we pass a value, x is standing in for a value. For example, 300, 700, 800, 900. And then, so we are telling it to return x raised to power 2. So this is what is going to be executed hapo ndani, right? X raised to power 2. Are you able to see that? So x, of course, how do you get squares of numbers? You have to raise it to power 2. If you are writing a function ya cube, then you'll call maybe this one is a cube, right? Function, then maybe x, then hapa utakuwa x raised to power 3. Return x raised to power 3, right? Yeah, so that is what is supposed to be returned. After running it, so R itakuwa inajua that we have declared a certain function here called square, right? Now you can use that function. How to use it? That is what we call calling a function. Now call it and say, even before writing that result, I want it to get for me square of 4. So I just use, you have to remember the function name. The function name was square. So square, and then maybe 4, or I pass in 8, or I can even pass in 90. I want to square now 90. So what it knows, it's going to take 90 and it is going to take here 90. So hapa itakuwa ni 90. So hapa suppose how you'd figure it out in this way now. Square function 90, blah blah blah. But when declaring the function first, hapa ikuangi mambo na a value. Hapa it has to be a variable. Variable is something that changes, right? So for example, x is a variable, right? And then return for us, not sorry, right? Return for us x raised to power 2. We have declared that function. Then now if you come here and say square of 90 and run it, unapata the answer is 8,100. Even if you have like square of 87 point, sorry, that value yenye unaona hapo. Okay. And maybe, so any value that you pass in there, it will have a square, right? You can see that as a square. Even if I pass in now a square of 0.5 and all that, you'll see the value iko hapo. If I pass in for it to find for me a square of 0, you'll find your answer there 0. Negative 4, 2, whatever, you'll find your answer there. So that is declaring a function, or calling a function, or writing a function and then calling it, right? Is anybody having a question on what you have done so far?
I would like you to repeat on the function of functions.
The function of functions. Yes?
Yeah.
Yeah, the function of function is to declare functions. Yeah. So you see, for example, so you're talking about this. What is the function of this? What is the function of this? So this is how you declare your functions. You have to use a function so that R will understand that whatever it is that we are saving here, whatever it is this that we are giving it a name here, it is a function, right? It's similar to the way, maybe, let me try to think of an example. Maybe list. You're doing something on list. For you to declare a list, you have to use here list, right? R will know now that that thing is a list. You want to declare a data frame, you have to use data dot frame. R will know that this is a data frame. So the function of function here is for R to know that this, whatever we have here, it is a function. Are we together, Hubert?
Yes, I'm okay.
Okay. Yeah, so that is that. You can even add another example, like what? For you to declare something as a matrix, you have to actually use matrix function, right? Even if you call that, so that if you write it as mat1, right, and write there matrix, right, and write your C there, maybe 1, 2, 3, 4, and things like that, right? Before you go to your end rows, very connected. I mean, matrix has to know, is going to know that mat1 is a matrix because you declared it by this matrix function. R is going to know that this is a function because you declared it by this function, I mean, or by this function. So that's it. I mean, yeah. Do an example. Can you write a function? Can you write a function that calculates the area of a triangle? Write a function that calculates the area of a triangle and then present it right now. Like, I want to pick randomly on somebody to present. If you don't get the question, I'm just saying write a function that calculates not even the area of a triangle, the area of a cuboid class. No, not the area, the volume, I mean. Volume of a cuboid class. in a minute. Joseph, you can present it for us, like your solution. Are you ready?
Not yet.
Yeah, how many minutes?
2.
Uh, or I want somebody to just be here and we'll guide you to share your screen so that we see the first things that you want to write. Pashamai, present your screen.
I'm using my phone, so I didn't log in using my laptop.
Where is your laptop?
It's here with me.
How about Evita? Yes, Ronnie.
I think I'm done.
Yeah, present. Uh-huh. Yeah, explain. Click on ignore and then continue.
Okay, here is the function cuboid volume. Then the parameters, the arguments are here, are the parameters don't know. So this is length, base times height. That's the formula, and height. Those are the parameters. Then
Let me see if you. Okay, continue.
yeah, the parameters ndo hizo, length, base, and height. Then what will be executed is multiplying the three. Then I call the function with the, I think these are the parameters, zile ni arguments with all this nini. This is a chini. Then I think it should run. Let me see. Yeah. Yes, the answer.
Are you conversant with? Are you okay with what Ronnie has done? Let me see. I'll watch. Thumbs up, thumbs down if you understand. Shema is okay. You can stop presenting. Evita? Anybody seeing blues? Yeah? Joseph? Yamwe?
Okay.
Yeah. So basically, that is how you'll write a function that calculates maybe the volume of a. You can think. So imagine that every time maybe you're working on a project that is calculating volumes here and there, you have to be calculating volumes of maybe. I mean, this is just like a dummy example, but maybe like imagine you're working on something that involves you using volumes here and there, and every time you have to calculate maybe the volume of a specific instrument or maybe a specific whatever it is you're working on, and then you have to be writing that code afresh kila time, right? Or imagine an instance where you have to find mean of something in R, and every time you have to write that code, it will be wasting time, right? So even for that thing that the code that Ronnie has written, every time you have values already, we're gonna call the function and then you just input them, right? Of course, it has to follow order because ameandika LBH, length, base, height, right? So it has to be like that. The inputs zenye unaleta pia it has to be in that order. If you change maybe length ilifaa ikuwe 12 and then we umeweka length yenye ilifaa ikuwe 12, width was supposed to be maybe 10, and then you interchange them. Of course, it is going to be running, but then you're going to get inputs which are wrong. So it has to follow like that order which you used, right? You don't have to write it as L only. You can even write it as we are talking about cuboid volume, or maybe class volume. Class volume. And you say that this is a function, and that hiyo pia ni refu sana. You can just maybe call it class and then say function. So function length, width, height, right? And then you have your, so what is it supposed to be returning for us? It is supposed to return length times width times height, right? So this is what is supposed to be returned. So if you sahau and then write here length without the G, of course you'll be calling for trouble. And then now you just call class and say, so you can now see it is found in the global environment. This is a function that we have now declared. You can see it is here, right? There are those functions which are inbuilt utaziona na maybe base or something. And then now input maybe your values. Height is 23, width is 45, and length is 23, 45, 878. And then you find your answer that it is this one. So depending on the metrics you're using, centimeter cube, blah, blah. Okay, I think that is understood. Anybody having a question there on functions? Nobody is having a function. The same thing that we wrote, you can even write it as maybe, so this is a function with default parameter. But look at here, now we are saying power. That time we are writing square, right? And now here we are declaring two things. So function x and maybe exponent is equaling to. So maybe you can change this to anytime, you can change it maybe to 3, 4, 5, and things of that sort. So function x and then exponent. Exponent is equaling to 2, right? Then return x raised to power of exponent. So raised to power of exponent. So if I change the exponent to 10, it still remains this raised to the power of exponent. Sorry, this was supposed to be 10 or 19. Or even exponent of 219, it will still be running. Right? If you run this, you'll see that it is running, and then now maybe press power and say power of, oh sorry, what was I writing here? Okay, yeah, so power function and then things like that, and then maybe right now power of Power of which value? So we want to input x. Power of maybe 2. So power is the function, right? So here we are saying 2 raised to power exponent, and the exponent is 219. So this 2 here, it is our x. So 2 raised to power of exponent, that is 2 raised to power 219, right? Here you can see using the function with default and custom parameters. Yeah, so there's that time maybe unaweza tumia hivi. There's another time where we can just write this one that we have here. So we can say maybe even power. So when I write power 5 and say 8, what does this mean? What does this one mean? This power 5, 8. What does it mean? I'm waiting for an answer on what this means. Victor? Victor,
Yes.
what does this mean when I say power 5, 8?
I'm not so sure about it.
Can you do a try?
Let me do.
Okay, let me try.
Uh-huh.
I think it is 5 raised to the exponent, which is 219, and 8 raised to 219.
Uh-huh. Power raised to. Uh-huh. How about yeah, that's a good try. How about Hubert?
Okay, I think we are changing our exponent to be 8.
We're changing our exponent to be 8. Uh-huh.
So it will be 5 exponent 8. If I'm not wrong.
Eric, how about you, Eric?
Not sure.
You're not sure. Have you tried writing it? But yeah. Ronnie, you also wanted to say something.
I think it means 5 raised to power 8.
Yeah, so let's try running it. That's why I did not run it prior. So you can see that our value is 39,396.25. So that means we have just changed our exponent. Initially tulikuwa tumesema exponent hapa ni 219, but right now we can even change it, right? You can even say, for you to see it very well, maybe sema 2 raised to power 3, which of course inafaa ikuwe 8, right? You can see that now. So it is not 2 raised to power 219 and 3 raised to power 219. Yeah. Ross, are we together? Thumbs up if we are together. Yeah, thumbs down. So where are you getting lost? Unmute if you can. Or type in the group if you can, not in the group, in the comment section if you can't. Eric, you also seem to be confused. Victor, are we together? Yes? Victor, are we referencing the one in 820? Anybody else mwenye amepotea? Thumbs down. Kama umepotea we've gotten from Victor and Aloch. Kama umepotea, thumbs down. Reaction. No more thumbs down. Okay. So what you're saying is we are creating a function calling it power. Let me say we even call it like what? Let me say it bar. Raise the bar high. So that is what you're trying to do, right? Or maybe set the standards. So you can even call it standards. You're setting the standards high. And then let's call it now, this is a function called bar. And this function, it has two components. It has component 1, which is x, and it has component 2, which is exponent, right? I can even say we don't declare anything there. We can say like function x exponent, and then return x raised to power of this exponent that we have. Let's try and run it. Object x not found. Why is it saying that object x not found? Okay, yeah, I was running it halfway. So suppose maybe now we have it this way, x exponent and things like that, right? If we have it this way, then it means we have two things. We'll be forced to declare, if we write just bar 2, hivi, you can see that the argument exponent is missing with no default. So venye tumeiweka hivi, we have to declare two things. We have to declare 2 for x, and we also have to declare another value for exponent. And maybe let's say exponent upon a 9. So 29, 512. But in that instance yenye tulikuwa na, let me just copy it again. And say bar, and then this exponent to 7, maybe exponent is equaling to 5, right? And say so if you run that one, then tunasema exponent is equaling to 5, and then x raised to power of exponent, but exponent tayari tushasema ni 5. So wakati we'll be running something here, it will just be knowing that this is same as saying x raised to power 5. Alright, so that even if I just write up a 9 peke yake, it already knows. Let's run it and see. If I write up a 9 peke yake, it has already taken care of hii mambo na 5 hapa. It knows what is supposed to be done. Return for us x and raise it to the power of exponent, but it knows already that the exponent is 5. So that's why si lazima we write it as maybe, what is this, 9 raised to raised to power 5 hivyo. We don't have to maybe write here and change it maybe to 15. Let me say 15, and you'll see things like that. All right. Are you getting anything from the explanation? Victor, Aloch, should we repeat once more? Evita? Yeah. So there's this function that you're trying to say. So example of a function with a default parameter. So I believe that this part, it is easier for you because it is similar to what we did here. It is similar to ni kama tu hii yenye tulikuwa tumeandika hapa, function length, width, height and things like that. If maybe this x is confusing, let me say we can even call it value, right? Value exponent, and then kuja hapo unasema value raised to power exponent. So the first entry yenye utaweka hapa inajua that this is for value. The second one yenye utaweka hapa inajua it is for exponent. So this one I believe it's easier because of the fact that tulikuwa tushaandika hapa. I hope you understood this one. The function for calculating maybe class volume. That one, if you got that one, then this one is also easy for you to understand. Function value exponent return for us value raised to power of exponent. So bar, the value that I'm passing in is 4. The exponent that I want to give you is 4. So 4 raised to power 4. And then I want to run all this one. Then you get that it is 256. Up to there, uko sawa, I'll watch. Cool. Let's go to this one. Let me just again even call it value. And then even call this one also value. So bar function value and then exponent is equaling to 5. So here I have already declared like what my exponent is, what my exponent is, right? So this one is just different from hii ya kwanza because I have declared what I want to use. I want to use 5 peke yake, right? So return value raised to similar to what we did up there. So here the only difference is hapa, that we have declared an exponent. We have declared the value for that exponent. Hapa juu hatu declare any value, tulikuwa tunaiacha hanging so that ni sisi tutakuwa tunai-change hapa, right? That is so that already R knows that the exponent yenye we are raising to is 5, right? I don't have to write that 5 when I'm writing, maybe, for example, I want now to use that function. Bar is, sorry, it's missing because I'm not trying this one. Yeah. I don't have to declare that 8 hapa tena 5. This will make it not any different from what we had in this case. Maybe it's but this one makes it easier for you because R already knows that you are raising to power of 5. The only variable that you can pass in ni hii ya value ndo ikuwe ikichange. But I can also even as well write it as 5 hapo. There's no harm. But I can just keep it clean this way. But the fact that I can also write 5 and then there is no harm, I can also write 10 and there is no harm. So that I say 8 raised to power of 10. So this one also now becomes now a variable. Exponent now becomes a variable. It's varying that way. So that if I run it, you have the value there. So that is more on that a lot. If it's confusing a little bit, we'll talk about it when you're done with the class. I mean, but these are functions. This is more or less on functions. Functions are user-defined functions. Depends on what you want to achieve. By the way, even with your data. So we have just looked at random examples that you can think of, but it just depends on. Sometimes you have a data and you want to create a function. Unataka kitu yenye I don't have to be writing that function every time I want to calculate something using my data, right? Or you can even declare that function so that even in future analysis zenye unafanya, it's more of automating things that you're doing. You don't have to write all those codes every now and then while you can declare them as functions. The same way functions, built-in functions zimerahisisha kazi. That is also why you may also want to make yours also. That word it's difficult to pronounce for somebody like me. Rahisisha. Okay. So let's look at loops. Let's look at loops. But before that, is anybody having a question? Yes. Any question? Okay. Let's go to loops. Anybody who know what a loop is? Yes. What is a loop and how is it really helping us? Joseph. Yes? Okay.
Well, I think
Yeah.
a loop is a control flow statement.
Uh-huh.
When, for example, if you set instructions to be occurring repeatedly, you can, that is when you say it's a loop. Maybe let's say today you'll be eating at 3 p.m. So tomorrow you're also eating at 3 p.m. So maybe in a week you are eating 3 p.m. thrice in a week. That's a loop. Yeah, just using a simple example.
Okay, yeah, you have to incorporate eating. Maso ingoho.
Yeah.
Okay. Yeah. There's a loop, I think I didn't want to, the things I've typed there that we need to start with okay. This one, like, we can push it down because if we start with this, everybody will be off. So Control X. I believe it's already there. Okay. Okay. Yeah. So we can look at loops, but start with this simple one. That example of a so we have different kinds of loops. For example, we have for loops, we have while loops, and we have repeat loops. So we have these three different types of for loops of loops, I mean. But in the examples I've given for and I've given a while, repeat loops I'll even share with you content here and there to refer to. But it's not different from what we have covered. We'll just maybe write a simple example of that. So loops for while, and then repeat. There are those three things that you can use. So for loops, example of a for loop is this. Maybe for I in 1 to 5, then print paste. Can you run this and see what is happening before, so that you go back to understanding it? It will be easier that way. Yeah. And then I'll ask you another question. So there's this example of a for loop, and then there's this one for a while loop. While. So for loop. So for I, maybe in 1 to 5, print. I think maybe you talked about what a paste function is, right? Paste function is used for concatenating numbers, not really numbers, but strings. You can concatenate strings and numbers. You can concatenate strings and strings, right? And that is something that we covered on day one. There's paste and also there's paste zero. Paste zero does not allow for space between the two things that you're trying to merge or maybe concat. So for a for loop, it starts with 4, right? For I in blah. Okay, let me see the skeleton here. So it's always 4. You start with this declaration, and then you can see that this is the general outlook for variable in a certain vector. Then you declare what is supposed to be done inside here. Is there anybody having a question with this skeleton? Or somebody has not understood the skeleton?
Just repeat once more.
Anybody else feeling the same? Evita, are we together?
Kindly repeat. Mine is bringing an error.
All those who are feeling okay, thumbs up. We do the poll. But of course, I'm repeating. I just want to see if I'm okay. Victor is okay. Anybody else who is okay? Those who are not okay, thumbs down. So where are the others? Okay, Pashamai, Hubert, Ronnie is okay, Moshiti is okay. There's somebody's Ross. Where are you? Are we together? Are you for us or you're for them? There's somebody here. Eric. Nathan. Nathan seems to be having problem. But yes, this one, if you type Kitu in your R in your console, it is going to come. Just start typing 4, and then you can see this one. It's written snippet, right? And then just press on tab or just click on it that way. You will be able to see these things. Sio mimi nimeandika hizi vitu mnaona hapa. Yeah, but this is like the skeleton of a for loop function, right? Yeah. So this is a skeleton, and it's telling you for Control Z. Yeah. So it is written here for. Now then we have a variable. So for the variable that we are looking for, is this variable found in a certain vector that you have declared, right? For every instance where we get that this variable is inside the vector, what are we supposed to do? Now curly brackets and those things. You're supposed to maybe return, you can even say maybe return that value, right? Or return, let me say return. You can even say maybe return the sum, or return, you can even maybe say return the sum of that value that you have, ongeza 1 to it, maybe ongeza 3 to it. I mean, like here you can declare so many things that you may want to be returned, right? Or you can say for every variable inside there, print something like print your name against that value, right? You can even print paste and paste, I mean to concat, and then maybe print something like maybe your name and then that number. So maybe if I have a group of a vector like maybe 10 to 23 or maybe 10 to 30, then for every instance where I get I is found inside that vector, then it is supposed to return for you something like maybe my name number 10, my name number 11, my name number 12, 13, 14, 15, 16. So that is depending on what you're going to be declaring inside here, what you're going to be declaring here. So this is just like the skeleton. This is not anything big. Actually, it is only big in terms of what you're supposed to be writing inside here. Yeah, what you're supposed to be writing here, up on the where the being big or not big comes in. So just try to master this, not really master, but just understand that this is the skeleton of a for loops function. This number 846 up to 848. This is the yes, Ronnie. I've just fixed it. You're supposed to understand that this is just the skeleton. I mean, it's not anything fancy or anything hard for you to not remember. Now, so here is where maybe now we are trying to write to write now a specific function, not really a function, but now a specific output that we are supposed to get. So think of it like for maybe I. Now I is now the variable. Variable is something that changes. For every I in maybe a number like even 0 to 15, or even 0 to 20, right? 0 to 20, or even like for I in 10 to 20, right? Print, what are we supposed to be printing? Before that printing, yeah, if a variable, if I is found between 10 to 20, right? Then print, there's this paste function that I was telling you. Paste is supposed to be concatenating number. It is supposed to concatenate number and I that is found in 10 to 20, between 10 to 20, right? We talked about those paste functions here. You can see somewhere where we are talking about I am part of and things like that, where we talked about paste 0 and and paste, just paste, right? And you can see maybe here where we are saying paste 0, part, cohort, and I like whatever. And then if you run it, you can see here. If you run this one, object cohort not found. Where is cohort? So cohort was for the InfoMinus class. And then if you write this one, then you can see I am part of the InfoMinus class and I like the progress so far. That is like using the paste function. That is paste 0. But if you use maybe paste, you can see what we did here last time. I'm just trying to bring you to book. Remember what we did here. Control Z, children in, and then maybe here we have. I remember this I gave you as part of what you are supposed to work on in class. If you go back to those initial places where we are using paste, I want you to just remember before we talk about mambo na paste yenye we are supposed to be using here. This one. Yeah, you can see you are supposed to write maybe a code that brings one out of 4 children in Europe suffer from obesity, right? And I gave you all these things. These were just like the entry points. And then you used paste, then 1, then comma, blah, blah, out of, comma, 4, comma, children in X. Then if you run this, object X not found. If you run this, you can see that it has concatenated them. Then you see 1 out of 4 children in Europe suffer from obesity. That was just like trying to bring you back to what we are doing today. So here, we were saying that for if a variable, if this variable I is a variable, is found inside this vector is a sequence of numbers from 10 up to 20, then you're supposed to print paste is just for concatenating, paste number, and then now maybe that I now is that variable. So suppose maybe I is 10, so it will say number 10. If I is 16, it will say number 16, right? So for loop, it will be looping through like our vectors, provided like that the condition that we have placed here has been met. So you can run this one and see what has been written there. Number 10, 11, 12, 13, 14, 15, 16, 17, blah, blah, up to hapo chini. Anybody having a question on that? Victor, are you okay? Eric? Rose? Pashamai? Joseph, okay. Nathan, Ronnie? Okay. Yeah. We are fine. So that is like a for loop function, right? Another difference now is while loop, right? There's for loop and then there's while loop, and then there's something that I did not mention to you is nested functions. You can have a function inside a function. Maybe we'll touch on it tomorrow, but tomorrow I wanted us to do more of like R Markdown. how you can publish or just write the same way unaandikanga kwa Word document. Unaweza andika code zenye zina appear tu just exactly that way. You just download them. Even all these explanations will be appearing there. But that is something that I wanted us to do tomorrow. So there is nested function and there is also repeat loops. Those two things have not been covered. While loop. Let's also look at while loop. Try to look at its skeleton. So you can see while here, right? And then while is just now you declare the condition. While loop into its skeleton, right? So here you have a condition. So that condition, you are declaring it here. And then yeah. So you declare it there and inside here now write what you want to be returned, right? The things that you want to see out of the operation that is going to be happening. Similar to maybe how we had a skeleton here, and then we said for variable and blah blah, and then inside here you are now writing what you want to be returned or what you want to be done by that function or by that for loop function. I mean, look at this example here, while loop. So from j, we are declaring j is equaling to 1. And then, so here you first have to declare maybe what value you are using, right? What value or maybe the variable that you're using. So while j is, even before that, try to look at this code for just 30 seconds and try to understand it before we give the explanation of what is happening or not. Yes? Yeah. So maybe let me remove this one. It might be distracting or something. But just of course, I believe you understand that these things are not going to be shown if you have it as a comment, right? So first we have to declare maybe a variable called j. Is it a variable or maybe this one is not a variable, but this is like what, an entry called j, right? So while, or you can say as long as j is less than 5, less than or equaling to 5. So you can say while, you can say as long as j is less than or equaling to 5, right? Now this is the condition. What are we supposed to be doing here? Print iteration blah blah j, right? Then what is our increment value of j? Like j in an increase na nini, because when it comes from 1, it is supposed to be increasing and checks if it is less than 5, right? It is not a one-time thing that is going to be written here. but it is something that is going to be, it meets this condition, moves to the next step and tries to look again, moves to the next step, tries to look again. That is how a loop function works. You're moving from something, going to the next until you reach a point where the condition that you declared is not being met. So for example, if it reaches 5, 5 less than or equaling to is 5, which is the value of j, less than or equaling to 5, then it finds yes, it is less than or equaling to 5. We can run that function. Checks maybe for number 6. Is 6 less than or equaling to 5? 6 is not less than or equaling to 5. It stops the action, right? It is now not going to be executing. So that is where now we are having now this increment. How are we increasing the value of j? So we increase it by taking j and adding 1. So if I have maybe j is, for example, j here is 1, then the next iteration is going to be based on 1, which is for j, plus 1. We have the new value of j here. 1 plus 1 is 2. The third iteration itakuwa value of j, which is 2 plus 1, which is now getting to 3. Similar way, hivyo. If it gets to 4, it will now take 4 plus 1 to become the new value of j, right? And that is basically how this while loop function is going to be working. So if I run this one, if I run this, I have already created it, right? What is wrong with our value here? Anybody seeing any issue with our, because it's supposed to be running? Let me copy it and see. Let me try running it here. Because I don't see any issue with it. What could be the issue? Can you try running it on your end and see if it's producing something?
Boniface.
Yes.
Yes, there is a problem. You left the first part.
Oh,
J. Yes.
Okay, let me see. Okay. Sorry. Yeah. Let me use this.
Yes. From there.
Okay. Yeah. I think that is the issue that you are having. Yeah. So are you able to understand what we are doing here? So you can see that maybe the iteration has stopped at number 5, because the next time we are looking at it will be that we are iterating from j, which was now 5 plus 1, to become 6. So if we come here and maybe plug something like 6, it will go and plug something like 6 and sees, is 6 less than or equaling to 5? Then it says 6 is not less than or equaling to 5 and stops that operation or stops that iteration, right? Iko sawa?
Okay, I have a question.
Yes.
Can that increment where you have said j j plus j is equals to j plus 1, can it be written as j and then we just write plus 1
That
the way you used to do in Python?
this way.
Yeah.
Can you try it and see? Curiosity killed the cat. You can see what is happening here. It is an endless loop, right? So
Yeah.
it's endlessly writing iteration 1, and it's not stopping anytime soon. You can see here interrupt, you can interrupt it. So kazi ni kuandika tu iteration 1. You can see all the crap that it has written there. Yes, these are iterations. So if you have to write it as j of course is equaling to j plus 1. Any question again? Can somebody also maybe understand this one, example 2? Yes? So you can run it this way. Somebody to explain this code. Somebody to explain all this thing. I've done explanation up with you. No, the one that you are working with now. Can somebody explain this line of code? Just volunteer and say something. Pashamai, say something about that line of code. Anything you think.
Okay, I think it is starting to print from 5 to 1. It is like it is minus. It is not adding.
Uh-huh. Yeah, so but again you can even see that inside our. So the first countdown that we have is number 5. Then we are writing while countdown is greater than or equaling to 1, as long as our countdown is greater than or equaling to 1, comma, print, of course this paste, now you know what it means. Print countdown, and countdown, right? And then you can see that countdown, a new countdown is equaling to countdown minus 1. But this first countdown here, it's 5, right? The first countdown here that we have is 5. So countdown is going to be equaling to 5 minus 1, right? The new countdown is equaling to countdown, which is 5 minus 1 tutapata ni 4. It finishes that and then iterates again, and now we are going to be using countdown as 4. So the new countdown is equaling to 4 minus 1, which is 3. The new countdown is again in the next iteration is going to be equaling to 3 minus 1, which is 2. So here will be 2, right? Yeah, so that is what this loop function is, what this while loop function is doing, right? It is basically trying to count going downwards, right? Because you can see we are coming from 5, 4, 3, 2, 1. So when does it stop? It will stop when the value of count that we have here is less than 1, right? Because here we have that as long as the countdown value is still greater than or equaling to 1, as long as it is still greater than or equaling to 1, we run and execute, right? As long as it is greater than or equaling to 1, the while loop function will be working. But when it gets to a point where the countdown is less than 1, then the operation will stop. Okay, that is what will be happening here. Yeah, so if you try to run that, you will be able to see countdown 5, countdown 4, 3, 2, 1. The next one will be 0, but then countdown here, we are very specific that you have to be greater than or equaling to 1. right? Anybody having a question with this? Yes. Any question? Okay. Seems like we are okay with that. These are just simple functions that we are writing. Functions and loops. Don't So you can also even look at this one. Calculate the sum of numbers from 1 to 10. Can you run it and see what is happening? Yeah, so you're calculating the sum of numbers from 1 up to 10. So there are two things that you're trying to declare here. Sum result, we are starting from 0. Number that we are starting with is tunaanza at 1, right? Okay. So while number is less than or equaling to 10, while number is less than or equaling to 10, then here we are declaring something. What is going to be our sum result? Sum result is going to be equaling to sum result plus number. Like, how are we going to be regenerating sum result? Right? It is by taking sum result, the previous one, then plus number from num. Hiyo yenye tumeandika num. And then how are we going to be getting new numbers? Right? Because if you just write it as, if you just leave it this way, then it is not a loop. If it's something that is going to be run just one time, itakuwa ina run to just only one time, right? Yeah, so sum result plus num and things like that. How are we going to be getting new sum result? How are we going to be getting a new number? So that is the while loop function there. And then print paste. This one is something that you are now conversant with, right? Here print paste blah blah. So if you run this one, you will see now the sum of numbers is 55. Yes? Are we okay? If you're okay, thumbs up. If you're okay, thumbs up. If you're not, thumbs down. Yeah, we are okay. Victor? Okay. Yeah, but again, these are things that really need practice and practice and practice. Writing functions, writing loops, writing while. These are things that are really challenging. So you need to really be constantly practicing. That will help you out. Okay. You can see what is the difference between for loop and while loop. Yes. What is the difference between for and while loop? Eric, any difference? Eric, how about Ronnie? Ronnie?
Yes,
What is the difference?
I think difference in structure. With the for loop, you put the increment first before the result, but with while loop, you put the increment after the result.
Yeah, but you can see here for loop is used when the number of iterations is known. When we know the number of iterations, then we use for loop. When you know how many times you're supposed to be iterating, it's a for loop. But for a while loop, you don't know the number of iterations that maybe you're supposed to be making. So maybe if I say here it's something that is less than maybe, can I say maybe 10.65, but I think it's just going to be running. Sum of numbers 55. Imetumia what whole numbers, I mean. Yeah, but I mean while loop and for loop difference is just on the fact that you can know the exact number of iterations in for loop, but you sometimes may not know all that information in a while loop. Okay, there are these examples that you wrote using inbuilt or built-in datasets. Yeah, take time to look at those 3 examples. Well, are they 3 or 2? 2. I mean, so there's this first one where we are trying to write a function to list cars from empty cars dataset with MPG greater than a specified threshold, right? So this is just supposed to be listing cars from the empty cars dataset which has MPG greater than a specified threshold. So you may just think of it as maybe list high MPG cars. We may want to just um, give it maybe though this name is really long, it can confuse you, but you just have to find a way in which maybe the name that you're working with makes sense for even somebody who will want to review your code. Review in terms of even just going through what you wrote, right? So even list high MPG cars, it's really, what do I say? It's a little bit long and it can confuse somebody. Yeah. Yeah, so we have list and then function. So here you have to declare. I think you know which you know the skeleton of maybe a function, right? Okay. So this one is more of like the condition that we want to pass in. Yeah. So maybe we are using data is equaling to MP cars. Then we have IMPG cars. So we are initializing a list to store the names of cars with high MPG. That is what we are doing here. And it will store it. So it will store it. This is a vector now. High MPG cars is a vector that you're going to use to store the names of cars with high MPG. And then now inside that function, now we are using now a for loop, right? For I in 1 up to n row, right? For I for I in so what is this one? So this one is telling you like for I in the first row up to the nth row, right? Up to the last row. Yeah. So it loops through each row in the data set. So it starts with the first row and then loops up to the nth row of our data, right? So this one here, which we are saying data, we had already talked about it as empty cars. So here doesn't have to be maybe data, it can be something like purity, it can be something like what. But if we write it here purity, then it means up here we wrote purity. Here where we are saying data is equaling to empty cars, you can say purity is equaling to empty cars, right? So for in 1 up to the end row is now the last row of our data set. For that, and then, so this is more of like a loop inside the function. So for I in that, if, yeah, you can see here, if what? So the row that you are busy with is the MPG, right? And then now we want to say if any value inside MPG, the column of MPG is greater than our threshold, right? If it is greater than our threshold, what are we supposed to see? You can see here what you wrote. If yes, add the car name to the list. So what we'll be having is maybe, of course, this one is high MPG cars. Now we are adding it to a list. Append high MPG cars, row names, data, and blah blah. Let's run it and so you see what the blah blah is all about. Sorry. I think this one should be running, right? Yeah, it's there. Then there's something that, okay. Yeah, so because this one was a function, high MPG cast. What is happening with my line of code? Okay. There is an issue. Call the function with threshold of 25. High MPG cast. Is there anybody noticing any issue with the lines of code that we've written? List. Who can notice any issue with the function? Yeah, this is where now functions become a little bit not really complex, but it's, I'm looking for a substitute for that. But here is where maybe now the loops and the functions get funny as you continue, because it really requires you to be very keen on what you're writing. I'm trying to see any issue with this one and I'm not finding. Okay, because this one is available there. Okay, let me run this one. Return that, and then now we can print this. There is an issue here. So who's seeing any issue? Paste. 1, 2. Okay. I don't know what I'm missing here, because this one is running, but there's something that I'm missing inside this loop function. That's why we are having a plus here. I think maybe I'll clean it and see. Okay, I think that one needs cleaning so that I see where the issue is. There's even another one that I was looking at here, a function to calculate average miles per gallon MPG in the MTCAS dataset. Yeah, this is also another one. Let me see if this one is going to run before we start the explanation. Here. Now there seems to be an issue. And something that I did not check. When you're having plus signs here, it's either there's an issue with my code or there's an issue with the console that is supposed to be running the codes. Okay. Yeah, I'll check on that. But you can go through like these lines of like the functions that are here. Though introducing that would really confuse you again, because you need to first soften or maybe lessen your heart with these simple ones before trying to go to complex ones. Because this one is from 920 up to 902, or the reverse 902 up to 920. It might be challenging for you. But we look at those two codes even tomorrow before we look at printing to your GitHub repository, printing to your LinkedIn, or printing to whatever it is, but printing or publishing or typing or using R Markdown. I'll try to look at what the issues are with this line of code. But that is more on like functions and looping through. Or I'll share even some line of code which are simple for functions. Is there any question? Any question?